If the consumption exceeds 200 milliampere, there is a high risk that there is a short in a secondary line. If the consumption exceeds 300 milliampere, it usually means a short in a secondary line. It is important to keep this in mind. What problems we might have when we turn on a device? Problems with initial consumption when we have not yet pressed the power button. We can have a consumption of 20, 30 or 50 milliamperes. It is already telling me that we have a consumption in the main line VBAT. This can be easily detected with a thermal camera or with Rosin technique. Fixed consumptions are those that remain stable without variation once the power laboratory supply is connected and the power button is already pressed. When we press the power button, the fixed consumption can be 50, 17, 100 or 200 milliamperes. The guilty one might be the PMIC, the CPU or the memory. Oscillating consumption is when a power laboratory supply is connected, the power button is pressed, and the consumption oscillates between 20, 50, and 70 milliamperes, and when we release the power button, it drops to zero. When we connect the device to the power laboratory supply, no initial consumption is observed nor after pressing the power button. The power laboratory supply remains at zero. For example, we can have problems with the power button. Next, we are going to see a couple of examples directly on the laboratory source. Depending on the model of the device, we can enter voltage to the motherboard in two ways. First, we solder a cable on the positive line of the battery and the other cable on any ground or any metal shield on the motherboard. We can also use crocodile clips if it's possible. There are some models that don't allow you to directly enter the current on the motherboard since they need to recognize the battery identification line. To avoid searching for resistors and soldering them on the line, I recommend you to recycle the damaged battery flexes. With 10 flexes, I managed to start most of the mobile devices, since these connectors are repeated in most of the models. Once we have soldered the cables to the motherboard, we use two crocodile clips to enter current. This initial consumption of the 7 milliampere source is due to the power Z and the cables used. Then, right after that, we have an initial consumption of 19 milliamperes. As you can see, we have a leak in the line. We press the power button to see the consumption and we observe a consumption of 75 milliamperes. After releasing the power button, the current reduced to zero. For this failure, we will have to make measurements on the motherboard, checking the input and output voltages of the PMIC. Finally, we have used a recycled flex from a battery, and it can be appreciated that the power laboratory source presents the same consumption. Analyzing the motherboard visually, it can be observed that it presents some broken parts in this corner. It is likely that the initial consumption is due to this. To confirm it, it is recommended to inspect the motherboard under a microscope. To connect the power Z to the source, there are two options. The first one is to connect it directly to the charging port if the source has the e-power function. And the second option is to connect it a female USB cable with two outputs, positive and negative. This can be easily achieved by soldering two cables to the female connector.